Before, we have seen how to perform data visualization using base R package. Now, in this session, we will perform advanced data visualization using a special package like ggplot2. ggplot2 is a system for declaratively creating graphics based on the grammar of graphics. Provide the data, tell ggplot2 how to map variables to a static, what graphical parameters to use, and it will take care of all the details. ggplot2 basically comprises of three important components. A static mapping, that is AES in short, is used to define the data for x and y axis, size positions, and more. So let's first load a sample data. Then we will define the AES mapping of our sample data using x is equal to mpg and y is equal to cyl. Now the second and the third components are geometrical objects, that is the geom underscore point, and the statistical transformation stat, often used to transform the data into counts, bins, density, etc. In this case, the stat is equal to identity, means no need to transform. For histogram, we'll do the same. AES x is equal to mpg. Here, we will have only one variable because we are aware that histogram is a univariate analysis. Then, we will define the second and the third component geom object geom underscore histogram, with stat is equal to bin. If we do the same without stat is equal to bin, we'll give the same because geom underscore histogram already contains a default stat value. Color blue will give blue border and fill green will fill up the bins with green color. To know more about the AES mapping, type help AES. And for the list of geom objects, use help alpha. Select ggplot2 from the objects exported from the other packages. Look at the index under G for the documentation of complete geom list. Let's try another example with more visualization. Up to this is same. Now to add labels in X and Y axis, we'll use XLab and YLab. If we want to use a single color, we will just mention the color name, and if we want to use color by groups, we will mention the variable name instead of the name of the color. For box plot, we'll use scale fill manual and the list of RGB color codes. Else, simply the names of the color will do the trick. For scatterplot, it's scale underscore color manual. Our color viewer is a package specially made for different sets of color combinations, so that it will help the analyst to create more elegant visualizations. To apply our color viewer, all we need to do is to define the set of colors by using palette. And for box plot, it will be scale fill viewer, and for scatterplot, it will be scale color viewer. To apply elegant gradient color effect, we have to define color range from low to high using scale color gradient for scatterplot and scale fill gradient for histograms. Regression lines is the line that best fits the trend of a given data, such that the overall distance from the line to the points plotted on the graph is the smallest. For continuous variable, we have to define geom smooth with method is equal to ln done. For discrete variable, additionally, we have to define SE is equal to false and full range is equal to true. Alternatively, to create a separate regression lines for each CYL, we have to define shapes is equal to CYL and AES fill is equal to CYL in geom underscore smooth. Done. We have separate regression lines for each CYL. Scatterplots with 2D density helps to represent the density if we have too many observations. To apply 2D density, we will just add geom underscore density 2D with geom underscore point. Adding a rock plot will help to add short lines to represent points for the existing plot to illuminate information that sometimes remains unseen. Again, just add the geom underscore log function Here, these are the run plots, each corresponding to a plot. Now, alternative to 2D density is the stat density underscore 2D, with GOM is equal to polygon. Our next type of scatter plots is with ellipses. Ellipses will help to group the overly populated observations of the scatter plot. To apply only one ellipse for all the variables, just add the function name density. Now, if we want it by group, then we have to define the grouping criteria in the AES mapping before we add the stat ellipse. Done. We can see the data has been clustered based on similarities. To increase the efficiency of the ellipse, type norm T or EUCLIT. These are the mathematical methods to calculate the distance, which we will have it in our machine learning concepts. But as of now, we can try any of them, as 3 of them will not make that difference in output. Another easy way to create scatterplot is by using a scatterplot function from the car package. First, install the package car, then define the variables mpg tilde qseg and the cyl in the scatterplot function. Done. We can see how intuitively the data is being visualized in the plot. Next, we'll perform how to plot multiple groups using facet, heat maps, geom density, and more.